Hello everyone, welcome to the new video lecture of subject Interconnected Power System. Myself Himanshu Joshi. I am an assistant professor in Sri Labhubhai Trivedi Institute of Engineering and Technology, Rajkot. So let's continue our topic from chapter number 2, that is the power system matrices. In our previous lecture we have learned about the formation of YBUS and ZBUS by means of singular transformation technique. Today we are going to learn one of the method which is used for the formation of YBUS, and that is the method of bus admittance matrix by means of direct inspection method. That method is known as direct inspection method, and it is used for the formation of YBUS or calculation of YBUS. So for that, consider the 4 bus network. Consider the 4 bus network in which this is the bus number 1, generator 1, bus number 2, generator 2, bus number 3, generator 3, and bus number 4, generator 4. The connection among these 4 bus is like this. One line is connected between bus number 1 and 2, bus number 1 and 3. So from bus 1 there is a 2 line which is connected between 1 and 2 and 1 and 3. Now for bus number 2, one line is connected between 2 and 1, one is connected between 2 and 3, and one is connected between 2 and 4. On the same way, from bus number 4, one line is connected between 2 and 4, one is connected between 4 and 3, and for the bus number 3 the connection are between 1 and 3, 2 and 3, and 3 and 4. So we can say that the total apparent power is given by the summation of apparent power which is generated or generator side and apparent power which is connected, which is given to the load. So total apparent power is equal to SGI plus SLI. Now the total generated apparent power which is equal to PGI plus QGI, total generated active power plus total generated reactive power, and SLI which is apparent power given to the load is given by PLI and QLI. We have taken the power which is negative because we want to differentiate that from the generator. So I will consider the positive sign of active and reactive power and negative sign for load active power and reactive power. So total active power is equal to PGI minus PLI and total reactive power which is equal to QGI minus QLI. So we can denote PGI minus PLI with simply PI and QGI minus QLI which is equal to QI. So this is the apparent power and this is the net active power and this is the net reactive power. So now our objective is to formation of YBUS for this network. We want to find out the YBUS matrix for this particular network. So let's try to draw the equivalent network for this particular diagram. So this is the equivalent network for the 4 bus network. Over here again the same thing, this is the generator 1, bus number 1, this is the generator 2 which is connected at bus number 2, this is the generator number 3 which is connected at bus number 3, and this is the generator number 4 connected at bus number 4. Now you can see over here that from bus number 1 two line is connected, one is connected at bus number 2 and one is connected at bus number 3. So that line is represented by means of this way. This is the line which is connected bus number 1 and 2, and this is the line which is connected at bus number 1 and 3. This is the admittance between line 1 and 2. This is the admittance between line 1 and 3. These are the shunt capacitance at each end of line. So now in the same way, these all are the line which is represented by means of admittance between their particular line. This is the admittance between line number 2 and 4. This is the admittance between line number 3 and 4. This is the admittance between line number 2 and 3. And similar way, their shunt capacitor at each end of line. So this is the equivalent network for that particular single line diagram. Now again we can modify this line so that we can derive the mathematical equation for this particular network. Now further modified, if I will further modify this diagram, then it will look like this. Now let me show the explanation for this modified equivalent network. This is the bus number 1, this is the bus number 2, this is the bus number 3, and this is the bus number 4, and this is the reference node. Clear? Once you understand this diagram, then the derivation of YBUS will be very much easier for you. So let me again show you. This is the node number 1, node number 2, node number 3, and node number 4. So 4 bus is equal to 4 node. So generator is connected between node 1 and reference node. So this is the V1, node number 1 to reference. This is V2, this is V2, node number 2 to reference. This is V3, node number 3 to reference, and this is the node number 4 connected between node number 4 to reference, that is the voltage V4. And these are the shunt admittance connected at each bus. These are the shunt admittance. You can see over here shunt admittance at each and every bus. So their admittance are also connected between node to reference. So this is the admittance at node 1, which is denoted by Y10. It is connected to node to reference. Similar way, this is Y20 connected between node number 2 to reference node. On the same way, this is Y30 which is connected between node number 3 to reference node, and similar way this is Y40 connected between node number 4 to node number 0. So Y10, in that 10 means between node 1 to reference node. We have indicate this node as 0 node or a reference node. So Y10 means admittance connected between node 1 to 0. Y30 means admittance connected between node 3 to 0. Y40 means admittance connected between node 4 to 0. On the same way, Y20 means admittance connected between node number 2 to node number 0. Okay. Now this is the Y12. That means this is the admittance between bus 1 and bus 2. Similar way, Y13 means admittance between bus 1 and bus 3. Y23, that means admittance between node 2 and node 3. On the similar way, Y34, that means admittance between node 3 and node 4. And the last Y24, that means admittance connected between node 2 and node 4. On this similar way, I1 that is the current from generator 1, I2 means current from generator 2, I3 means current from generator 3 and I4 means current from generator 4. So, this is our final equivalent network for the 4 bus network which we have considered for the formation of YBUS. So, now let us try to derive the YBUS for this particular network. So, for that we are going to apply the Kirchhoff current law at all the nodes from node number 1 to node number 4. So, take a screenshot, I will erase this all. Okay. So, now we are going to apply the Kirchhoff current law for this particular node. So, as per KCL we can say that injecting or incoming current is equal to outgoing current. Incoming current is equal to outgoing current. So, incoming current is only one, that is equal to I1, rest of the current are outgoing. So, over here 4 lines connected at node 1 in which one is incoming and 3 is outgoing. So, we can say that this I1 is equal to total current which is outgoing from node number 1. So, we can say that this is our V1, this is our V2, this is our V3 and this is our V4. So, we can say that the current from this branch is given by, in terms of admittance if I will talk, then we can say that I is equal to V into Y. In general formula for current is I is equal to V into Y. So, if I will talking about this branch current, then it is equal to the potential difference between these two terminal multiplied by the admittance. Similar way, if I will talk about this current, then it is equal to the potential difference multiplied by this admittance, and this current is equal to potential difference multiplied by the admittance. So, I can say that I1 is equal to V1 into Y10, because potential difference for this branch is only V1, potential difference for this branch is V1 minus V2 and for this branch is V1 minus V3. So, finally, I1 is equal to V1 into Y10 plus V1 minus V2 into Y12 plus V1 minus V3 into Y13. So, again we will multiply this Y12 with V1 and V2. On the similar way, we will multiply this Y13 with V1 and V3. So, next equation is I1 is equal to V1 into Y10 plus V1 into Y12 minus V2 into Y12 plus V1 into Y13 minus V3 into Y13. So, we can say that we can take V1 is common from these 3 terms. So, V1 into Y10 plus Y12 plus Y13 and same way minus V2 Y12 minus V3 Y13. Now, if I want to write entire equation in positive sign, then we can take this negative sign, we can give this negative sign to this admittance. So, the final equation I1 is look like this, I1 is equal to V1 into Y10 plus Y12 plus Y13 plus V2 in bracket minus Y12 plus V3 in bracket minus Y13. So, this is our final equation for the formation of YBUS at node number 1. Similar way, we can write KCL at node number 2 and it will look like this. At node 2, total number of branch is equal to 1, 2, 3, 4 and 5, in which one current is incoming, remaining 4 are outgoing. Remaining 4 currents are outgoing. So, potential difference for this branch we can take V2 minus V1, For this we take V2 minus V3, and for this we can take V2 minus V4, and for this particular admittance only V2 voltage is available. So at node 2 equation for I2 is look like this: I2 is equal to V2 into Y20 plus V2 minus V1 into Y12 plus V2 minus V3 into Y23 plus V2 minus V4 into Y24. Again we will multiply Y12 with V2 V1, Y23 with V2 V3 and Y24 with V2 and V4. So after multiplying we will take V2 is common from this all 4 elements. So and again we will take this minus sign, we will give to all admittance in this term, in this term and in this term. Okay. So V1 into minus Y12 plus V2, the remaining term are Y20, Y12, Y23 and Y24. So V2 into in bracket Y20, Y12, Y23, Y24 minus V3, Y23 minus V4, Y24. So final equation for KCL at node 2 for the formation of YBUS will look like this. On the same way, let's apply KCL at node number 3. So I3 is equal to V3 Y30, V3 minus V1 Y13, V3 minus V2 Y23 and V3 minus V4 Y34. Because at node 3 you can see that potential difference for Y13 is V3 minus V1, for Y23 is V2 minus V3, for Y34 is V3 minus V4 and for this Y30 is only V3. So incoming current is I3, 1, outgoing currents are 1, 2, 3 and 4. These 4 are outgoing current. So this is only incoming current, this 1, 2, 3 and 4 are outgoing current. So again we will multiply Y13 with V3 and V1, Y23 with V3 and V2, Y34 with V3 and V4. So again we will take V3 will be common from 1, 2, 3 and 4. And again we will give this minus sign to respective admittance. So finally I3 will look like this: V1 into minus Y13 plus V2 into minus Y23 plus V3 into the common from these 4 term Y30, Y13, Y23, Y34 plus V4 into minus Y34. So that is the KCL at node number 3. On the similar way you can write KCL at node 4. Incoming current is equal to outgoing current. Potential difference for Y24 is V4 minus V2 and potential difference for Y34 is V4 minus V3. Again multiply Y24 with V4 and V2 and Y34 with V4 and V3. Again over here you can observe that there is no connection of branch between node number 4 and node number 1. Clear? You can see over here that there is no connection between node number 4 and node number 1. So you can write over here 0 V1. Admittance is 0 between node number 1 and 4. So you can add 0 V1. If you don't write, doesn't make any sense. So final equation for I4 is given by V1 into 0 plus V2 into minus Y24 plus V3 into minus Y34, and you can take common V4 from this 3 term. So remaining term is plus V4 into Y40 plus Y24 plus Y34. So these are the KCL equation at node number 4. So these all are the equation that we have derived by using Kirchhoff current law from node number 1 to node number 4. So now to find out the YBUS, we have to rearrange this equation and rewrite in terms of matrix form. So we can say that this is the matrix for I and this is the matrix for YBUS and this is the matrix for voltage. So this is our YBUS. This is our YBUS for the 4 bus system that we have considered. So this is the YBUS for the 4 bus system for our example. So from this we can write the general formation for YBUS in broader way or in general way. So I can write the standard formation of YBUS will look like this: Y11, Y12, Y13, Y14, similar way 21, 31, 41 to last Y44. So in this particular YBUS matrix, these elements are known as diagonal elements. These elements are called diagonal elements, and the remaining elements, these remaining elements are called off diagonal elements. The remaining elements called off diagonal elements. So let compare the diagonal elements, generalized diagonal elements with our 4 bus matrix. So for Y11, so this is our Y11, this is Y22, this is Y33 and this is Y44. So Y11 is equal to Y10 plus Y12 plus Y13. Similar way Y22 is equal to Y20 plus Y12 plus Y23 plus Y24. Y33 is equal to Y30 plus Y13 plus Y23 plus Y34, and Y44 is equal to Y40 plus Y24 plus Y34. So this is the diagonal elements for 4 bus system. Now let's consider the off diagonal elements. So off diagonal elements are Y12 and Y21, Y13 and Y31, Y14 and Y41. Similar way Y23, Y32, Y24, Y42 and last Y34 and Y43. So off diagonal elements are look like this: Y12 is equal to Y21, that we have already know, and it is equal to minus Y12. Y13 is equal to Y31, which is equal to Y13. Y14 is equal to Y41 is equal to minus Y14. But in our case, there is no connection between node number 1 and node number 4. So entry in that case is equal to 0. Y23 is equal to Y32 is equal to minus of Y23. Y24 and Y42 is equal to minus Y24, and last Y34 is equal to Y43 is equal to minus Y34. So these are the formulas for off diagonal element of YBUS. So this is the general way to represent the YBUS matrix. Suppose there are n bus. So dimension of YBUS will be n cross n, starting from Y11 to ending at YNN. So this is the general representation for YBUS matrix. So what are the steps that we should follow for the formation of YBUS by means of inspection method? Which are the steps that we have to follow if we want to derive the YBUS matrix for given network? So the step number 1 is to make the equivalent circuit from given single line diagram. That means this is our single line diagram, and from this we have to make the equivalent network. equivalent network from the given data of particular example. If you have given the example, then the admittance data will be given to you. So from that you can make the equivalent circuit from that single line diagram by using that admittance data. Step number 2 is observe the dimension of matrix YBUS. So the dimension of matrix is n cross n. For n bus system, the dimension is n cross n, where n is the number of buses or number of nodes. And generally we are having one extra node that we have considered for reference node. So the total number of node will be n plus 1, because n is the total number of buses and the extra plus 1 is our reference node. Step number 3. So first of all we have to find out the self admittance, that means diagonal element. In our YBUS there are two types of representation: diagonal element, that is known as self admittance, and off diagonal elements. So first of all we have to find out the self admittance, that is y11, y22 up to end of the node. So self admittance of node m, suppose there are m number of node. So self admittance is the summation of all admittance of element connected to node m. So this is the general formula for self admittance. Over here you can see that the self admittance is the addition of all the elements connected at particular node. So y11 is equal to addition of all admittance that is connected at node 1. So y10 plus y12 plus y13. y22 is equal to the addition of all admittance at node 2. So y20 plus y21 plus y23 plus y24. So y33 is equal to the summation of all admittance connected at node number 3. So y30, y31, y32, y34. Similar way, y44 is equal to addition of all the admittance connected at node number 4, y40 plus y24 plus y34. So in general self admittance of node m is the sum of all admittance connected to node number m. So general formula for self admittance is given by YMM is equal to summation from p equal to 0 to n YMP. That means if you want to find out, suppose y55, then y55 is equal to summation of all the elements admittance, summation of all admittance connected at node number 5. That means y50 plus y51 plus y52 plus y53 plus up to end of all node. So this is the general formula to find out the self admittance of YBUS. For example, y11, what is equal to y11? All the elements, summation of all the elements admittance connected to node 1, or you can say bus 1. Now the last step is to find out the mutual admittance between node, which is equal to negative of admittance between the nodes. So this is also one of the simplest formula. Over here you can see that y12 is equal to minus y12 or y21 is equal to minus y12. Simply we have to take the negative sign. So if you want to find out, suppose y23 or y32, it is nothing but the equal to negative sign of that admittance connected between node number 2 and 3. So that this is the formula for the mutual admittance connected between two node. Suppose you want to find out YMP or YPM, which is simply the negative sign of YMP. So what is equal to Y12? That is the negative summation of all admittance element connected between node 1 and node 2 or bus 1 and bus 2. So Y12 is nothing but the negative sign of Y12. So that is the step number 4. So this is the way to formulate the YBUS by just means of inspection method. Now next, another important point is modification of existing YBUS. So once you format the YBUS, there might be possible that the entries of that YBUS will get changed. So if some elements are added in the network, then entries of existing bus admittance matrix will be affected. Suppose any branch will add, then the existing YBUS will get changed. So that change will depends on the location of element. Clear? So that change in YBUS will depends on the location where that element will be added. So there are two types of cases that we will consider for the modification of YBUS. So case number 1. So consider the element having admittance YMN is connected between bus number M and bus number N. Suppose new element will be connected between bus number M and bus number N, and that new element having admittance of YMN, that admittance is equal to YMN. So due to this addition of element, there are 4 entries will get changed. There are total 4 entries in YBUS matrix get affected. That 4 entries are, this is 1, this is 2, this is 3 and this is 4. So 4 entries means self admittance at bus M, self admittance at bus number N, mutual admittance YNM and mutual admittance YMN. It is but obvious that if any element will added to bus number M, then self admittance and mutual admittance will get changed. So in such case there are 4 entries in YBUS will get changed. So we can say that YMM new, that is the new value of admittance YMM, which is equal to YMM old, that is the previous value, plus the admittance which is added between bus number M and N. So YMM new is equal to YMM old plus YMN. Similar way, YNN new is equal to YNN old plus YMN, and the mutual admittance is equal to YNM new is equal to YNM old minus YMN. Sorry, over here YMN. On the similar way, YMN new is equal to YMN old minus YMN. So self admittance or diagonal element, you have to add that particular admittance, and for mutual admittance you have to subtract that particular element. So that this is the modification that will occur when elements will added between 2 buses. So if a single element will added between 2 buses, then there are 4 modification. 2 modification are in self admittance, 2 modifications are in mutual admittance. So this is the simple case number 1. Now consider the last case, that is case number 2. So consider the element is connected to mth bus to reference node. In case number 1, we have connect the element between 2 bus. Now consider the element is connected between bus, new bus or bus to reference bus. So in that case, single element will get affected, and that single element is self admittance only. So YMM new is equal to YMM old plus YMN. So YMN, that is the new element connected from M bus to ground. So if any element is connected to single bus to reference, then only self admittance of that particular bus will be affected, and that new value is equal to old value plus that admittance which is connected between that particular bus to reference bus. So this is the case number 2 and last modification for YBUS formation. Now, what are the advantages of bus admittance matrix? So first advantage is that the preparation of data is simple and reliable. It's the easiest way to formation the YBUS compared to the formation of ZBUS. So preparation of data is simple and reliable. It is easy to modify the YBUS matrix compared to ZBUS. It's easiest way that only 4 changes are there if element is connected between two bus, and only single changes is there if element is connected to reference bus. So modification is easy. Bus admittance matrix is a sparse matrix. Sparse matrix means that in that particular matrix most of the elements are 0, and you can see that in case of YBUS most of the elements are 0 because the 90% of buses are not connected to each other. So most of the entries in this particular bus admittance matrix is 0. So it's a sparse matrix, and if most of the entries are 0, then memory required by computer is less. Memory required is less, and if most of the entries are 0, then we can say that fast mathematical operation and round of error is very much reduced, and we can say that direct solution by using triangularization technique can be obtained. So these are the advantages of bus admittance matrix. It's simple, reliable, modification is easy, sparse matrix most of the entries are 0, and due to that computer memory required is less, fast mathematical operation, less error because most of the elements are 0, and triangularization technique can be obtained or it can be used. So these are the advantages of bus admittance matrix. So the question arises in mind that why admittance matrix is sparse matrix? Why admittance matrix is sparse matrix? So you can say that admittance matrix, each non-zero of diagonal element correspond to a network branch connecting the pair of buses indicated by row and column of the element. So over here let me show you matrix. So this Y12 means there is a branch which is connected between bus 1 and bus 2. Y13 means there is a connection between a branch between node 1 and node 3, and similar way Y23 means there is a connection of elements between bus number 2 and bus number 3. Now if you see that if there is no connection between bus 1 and bus 3, then this element is equal to 0. On the similar way Y31 is also 0. Clear? Suppose if Y12 there is no connection between bus 1 and 2, then this Y12 and Y21 both are 0. So if there is a single connection is not exist, then there are two elements which are equal to 0 in case of YBUS. So in practically you can find that majority of branches are not connected to each other. Majority of branches are not connected to each other. So we can say that there are lots of zeros in our YBUS. There are lots of zeros in our YBUS, and that's why it is known as sparse matrix. That's why it is known as sparse matrix. So that is due to the irregularity in their connection and arrangement. So no connection between two elements, then there are two entries which is equal to 0 in YBUS, and lots of elements are not connected to each other. So there are most of off diagonal elements are 0. So we can say that bus admittance matrix is relatively a sparse matrix. Now comes towards the ZBUS matrix. So V is equal to I into ZBUS, or I is equal to V into YBUS. So we have till now we have learned about the formation of YBUS. So if we have YBUS, then we can take the inverse to find out the ZBUS, or if we are having a ZBUS, then we can take the inverse of that ZBUS to find out the YBUS. So it's a one of the way to find out the ZBUS. So admittance matrix is the inverse of impedance matrix and vice versa. So once you have YBUS, you can find out the ZBUS by means of inversing that matrix. So this is the one of the way to find out the ZBUS. But in our next lecture, we are going to learn about the new way to find out the ZBUS. So Z is equal to R plus Jx, as you all know, resistance plus inductance, and Y is equal to G plus JB, G plus GB, that is the conductance. G means conductance and B means susceptance. So this is the information for ZBUS matrix. So thank you very much. With this we will conclude our session. In our next lecture we are going to learn about the formation of ZBUS. So with this we will conclude our session. Thank you very much. If you have any doubt, any question, you can give your doubt and question in comment section. And if you like my video, then please like it, share with your friends and colleagues. And if you have not subscribed my channel, my YouTube channel, then please subscribe my YouTube channel. Thank you very much.